September 2013, Kwajalein Atoll, Western Pacific Ocean, 4 o'clock in the morning. HMS Daring, Britain's newest destroyer, sits perfectly still in the dark water. 3,400 nautical miles from home, American missile test range all around her. On the bridge, Lieutenant Commander Sarah Mitchell, 38 years old, 15 years in the Royal Navy, radar warfare specialist, stares at her display. Watching, waiting. She knows what's coming. 2 missiles, ballistic missiles, medium range, launched from somewhere over the horizon, travelling faster than anything she's ever tracked, 5 kilometres per second, Mach 15. The mission? Simple. Detect them. Track them. Prove that a British destroyer can see what she was never designed to see. The Americans think it's impossible. The Samson radar, that distinctive spherical antenna rotating atop Daring's forward mast, wasn't built for ballistic missile defence. It was built for aircraft, for cruise missiles, for targets that fly low and slow. Not for missiles that punch through the atmosphere, that travel in space, that come down like meteors. But the British engineers said, let's try. Let's see what Samson can really do. At 0403, the first missile launches. Somewhere in the darkness. Rocket motor igniting. Climbing. Samson is scanning. 2 hexagonal arrays rotating at 30 revolutions per minute. Thousands of individual radar elements, each one controlled by software, each one searching. Then a signal, faint, high altitude, moving impossibly fast. Lieutenant Commander Mitchell leans forward, calls out, "Contact, bearing 270, high velocity, ballistic profile." The display updates. A red track, climbing, arcing, following the perfect parabola of a missile re-entering atmosphere. Then the second launch, another signal, another track. Samson is tracking both, simultaneously, updating every fraction of a second, calculating trajectory, predicting impact point. The American observers in the control room are stunned. They expected Samson to lose the tracks, to fail, because this isn't what the radar was built for. But Samson doesn't lose anything, tracks both missiles from launch to splash, every second, every meter. And when it's over, when the test is complete, BAE Systems issues a statement. Samson exceeded expectations in all respects. Exceeded expectations. The British way of saying, we built something extraordinary. And nobody, not even us, fully understood how good it was until we tested it. That day in 2013, Britain proved something the world didn't expect. The Samson radar isn't just advanced, it's revolutionary. It gives the Royal Navy capabilities that only America has, capabilities that change the game. And every British citizen should know this, should feel what Lieutenant Commander Mitchell felt that morning. Not arrogance, not boasting, pride. Quiet, solid British pride. The pride that comes from doing something properly, from building something that works, from showing the world, once again, that Britain leads. The Samson radar looks distinctive, a large sphere mounted on a tall mast, rotating slowly, almost elegantly. Most people see it and think, interesting design, quite modern, very British. But Samson isn't just a radar. It's the culmination of 30 years of British research, 30 years of pushing technology forward, 30 years of refusing to accept second best. The story begins in 1982. The Falklands War has just ended. HMS Sheffield, a Type 42 destroyer, lies at the bottom of the South Atlantic. sunk by a single Exocet anti-ship missile. 20 men dead. Britain's most modern destroyer destroyed in seconds. Because the radar didn't detect the missile in time. Because the systems weren't good enough. The Ministry of Defence convenes a review, asks the hard questions. How did this happen? Why weren't we prepared? What do we need to change? And the answer is clear. Britain needs a revolution in 75 radar technology, not incremental improvement, complete redesign from first principles. Enter the MESAR programme, Multifunction Electronically Scanned Adaptive Radar, a partnership between the MOD's Defence Research Agency, Roke Manor Research and Plessey. The goal? Build an active electronically scanned array radar that can do everything simultaneously. Track aircraft, track missiles, guide weapons, detect stealth, resist jamming, all at once, all perfectly. Other countries are working on similar technology. America with Spy-1, the Dutch with APAR, but Britain wants something better, lighter, more flexible, more capable. From 1982 to 1995, British engineers developed MESAR-1, an S-band prototype, testing concepts, proving principles, building knowledge. Then MESAR-2, more advanced, more refined, closer to operational reality. And finally, after years of work, millions of pounds, countless tests, Samson, production ready, ready for deployment. The first Samson radar is installed on HMS Daring in 2006, first of the Type 45 destroyers. Britain's answer to modern air warfare. And from the moment Daring puts to sea, the world notices. Because Samson is different. Fundamentally different from anything else afloat. What makes Samson so special? Architecture. Most naval radars use fixed panels. American Spy-1 has 4 panels arranged in a square. Dutch APAR similarly. They provide 360-degree coverage by having multiple arrays pointed in different directions. Samson uses 2 back-to-back hexagonal panels, rotating at 30 RPM, only 1 second coverage, half a second average. Sounds like a disadvantage, but it's actually brilliant, because fewer panels means less weight, less power, less complexity, and less weight means Samson can be mounted high, very high, on a slender mast at the top of the ship. Why does height matter? Because radar is limited by horizon. The higher the radar, the further it can see, especially against low-flying threats, sea-skimming missiles, aircraft hugging the waves. Samson sits approximately double the height of equivalent radars on American or Dutch ships, which means it sees further, earlier, better. Capabilities. Samson can track hundreds of targets simultaneously. Some sources say 400, others say more. The exact number is classified, but everyone agrees it's impressive. More importantly, Samson can track small targets, fast targets, difficult targets. The US Naval War College published a study, states that Samson can track 1,000 objects the size of a cricket ball travelling at Mach 3. 1,000. Cricket ball. 3 times the speed of sound. Think about what that means. A stealth aircraft, designed to be small on radar, looks larger than a cricket ball. Much larger. So if Samson can track 1,000 cricket balls at Mach 3, it can definitely track stealth aircraft, stealth missiles, stealth everything. This isn't theoretical. This is proven, documented, acknowledged by American experts. Electronic. Countermeasures. Enemy aircraft and missiles use jamming, electronic noise, trying to blind radars, make them see ghosts, miss real targets. Samson is designed to resist jamming, uses pulse compression, frequency agility, can switch between hundreds of channels and waveforms, each optimized for different scenarios. Result? Samson is virtually immune to jamming. That's not marketing, that's official BAE Systems documentation. Adaptive software. Samson's performance isn't fixed, it's software driven, which means it can be updated, improved, enhanced without physical modifications. When new threats appear, update the software. When new tactics develop, rewrite the algorithms. This is why Samson detected ballistic missiles in 2013, not because it was designed for that role, but because British engineers wrote new code, new algorithms, and suddenly Samson could do something impossible. But here's what most people don't understand. What makes Samson truly remarkable? It's British. Completely, entirely, thoroughly British. Designed in Britain, by British engineers, built in Britain, at BAE Systems facilities in Cowes, Isle of Wight. Not purchased from America, not licensed from Europe. Developed from scratch, using British expertise and British innovation. This matters. This matters immensely, because when you depend on foreign technology, you depend on foreign goodwill, foreign priorities, foreign politics. America decides to cut support, you're vulnerable. Europe changes policy, you're exposed. But when the technology is yours, when every line of code, every circuit board, every algorithm is British, you have control. Complete control. If something breaks, fix it. If something needs improvement, improve it. If a new threat appears, adapt. No permissions required, no export licenses, no negotiations, just British engineers doing what they've always done. Solving problems, building solutions, making things work. This is sovereignty. Real sovereignty. The kind that matters in war. And Britain has it. With Samson. With Type 45. With the Royal Navy's most capable destroyers. Now the question. Does Samson actually perform in combat? Answer: yes. Absolutely yes. Red Sea, 2024. Iranian-backed Houthi forces in Yemen launch ballistic missiles at shipping, targeting commercial vessels, creating chaos. HMS Diamond, a Type 45 destroyer, is on patrol, protecting British interests, maintaining security. A Houthi ballistic missile launches, short range, but dangerous, fast, deadly. Diamond's Samson radar detects it immediately, tracks the trajectory, calculates intercept point. The crew launches an Aster 30 missile, guided by Samson's data, precise, accurate. The Aster intercepts the Houthi missile, mid-air, destroys it completely. 0 damage to shipping, 0 casualties, mission accomplished. But here's the important part. HMS Diamond wasn't originally designed for ballistic missile defense. The Aster 30 wasn't optimized for that role, but Samson made it possible. Because Samson saw the threat early, tracked it accurately, provided the data needed for intercept. This is what British technology does. Performs beyond expectations, adapts to new challenges, succeeds when others fail. Black Sea, 2018. HMS Duncan, another Type 45, operates in international waters, monitoring Russian air activity. Russian aircraft fly constantly, testing, probing, looking for weaknesses. Su-27 fighters, Tu-95 bombers, various electronic warfare platforms. Duncan's Samson tracks everything. Every aircraft, every manoeuvre, every pattern. British operators build a complete picture, understanding Russian tactics, Russian capabilities, Russian intentions. This intelligence is shared with NATO, with allies, with everyone who needs to know. Because that's what Type 45 does. Not just defend, inform. Provide situational awareness to entire fleets, entire regions. One destroyer, with Samson, performing the role of multiple ships, multiple systems, all at once. But there's something else, something the British public needs to understand. Samson isn't just about technology, it's about history, about legacy, about continuing a tradition that goes back 80 years. Britain invented radar in the 1930s, before World War II, when most nations didn't even understand the concept. British scientists, led by Robert Watson Watt, developed the first practical radar systems, installed them along the coast, the Chain Home network. These radars saved Britain. During the Battle of Britain, gave warning of German bombers, allowed fighters to intercept, prevented invasion. Without radar, Britain might have fallen. The war might have been lost. History would be completely different. And now, 80 years later, Britain leads again. Samson continues the tradition, proves that British radar expertise didn't disappear, didn't fade, grew stronger. Engineer David Thompson, 57 years old, 30 years at BAE Systems, worked on Samson from the beginning. From MESAR prototypes to production units. He remembers visiting Chain Home sites, old radar towers still standing, preserved as monuments. Standing there, looking at those ancient structures, David felt something. Connection, responsibility, pride. My grandfather worked on Chain Home, David says quietly. During the war, he was young, barely 20, but he did his part, helped save Britain. And now I'm doing the same. Different technology, different war, but same purpose. Protect Britain, keep us safe. That's what British engineers do, have always done, will always do. Build the systems that defend our nation, not for glory, not for profit, because it's right, because it matters, because we can. This is the soul of Samson, not just circuits and software, but people, British people, carrying forward a tradition, honouring those who came before, building for those who come after. Now here's where it gets interesting, the part most people miss. Samson's success has created questions in NATO, not negative questions, complicated ones. Because for 70 years, NATO assumed certain things. America had the best technology, the best radars, the best systems. Everyone else bought American, or tried to keep up. But Samson challenges that. Not aggressively, not arrogantly, just by existing, by performing, by being excellent. When American analysts study Samson, they acknowledge it's different, perhaps in some ways better, certainly more innovative. Nick Brown, editor of Jane's International Defense Review, was quoted, "The US Aegis system is similar, but Sea Viper is more advanced than America's premier naval air defense system. That's not British propaganda, that's independent analysis. And NATO notices. NATO wonders, if Britain can build this alone, without American help, without massive budgets, what else is possible? What if European nations cooperated, pooled expertise, combined resources? Could Europe develop sovereign systems, independent of America, capable, reliable, competitive? These are uncomfortable questions, because they suggest that Europe doesn't need to depend on America, that Europe, led by Britain, could stand alone. And in 2025, with American politics uncertain, with transatlantic relationships strained, these questions matter more than ever. Britain didn't set out to create panic. Britain set out to defend itself, to build excellent systems, to maintain sovereignty. But by succeeding, by building Samson and Type 45, Britain changed the equation, showed what's possible, inspired others. That's power, real power, not military force, not economic size. Technological excellence, innovation, capability, and NATO, watching Britain operate Type 45 destroyers, watching Samson track everything, watching British engineering triumph, feels something new. Not fear, not concern, respect, and perhaps a little envy. Final scenario, hypothetical. Year 2028. Tensions rise in the Arctic. Russia increases military activity. Testing, provoking, challenging. NATO responds, assembles a task force. American destroyers, Norwegian frigates, German support vessels, and HMS Duncan, Type 45, with Samson. The task force enters disputed waters. Russian aircraft appear immediately. Su-35 fighters, Tu-142 maritime patrol aircraft, shadowing the NATO ships. Russian tactics are sophisticated. Multiple aircraft approaching from different directions. Electronic jamming, confusing radar pictures, testing defences. American destroyers struggle slightly. Their Spy 1D radars are excellent, but overwhelmed. Too many targets, too much noise. Saturation attack tactics. HMS Duncan? Calm. Samson tracks everything. Every aircraft, every manoeuvre, every jamming signal. The British Combat Information Centre builds a complete picture, classifies every target, predicts every movement, sees through the confusion. Then Duncan does something crucial, shares the picture with the entire task force. Via data link, real time, perfect clarity. Suddenly, the American destroyers see clearly. Norwegian frigates understand the situation. German vessels know where everyone is. The task force operates as one, coordinated, efficient, unstoppable. Russian aircraft withdraw. Mission failed. Because they couldn't overwhelm the defences, couldn't create confusion, couldn't exploit weaknesses. Because Samson saw everything, and shared everything, and made the impossible simple. The American admiral commanding the task force sends a message. HMS Duncan performed exceptionally. Samson radar capabilities exceeded requirements. Royal Navy is an invaluable asset to NATO operations. Exceeded requirements. There's that phrase again. The British trademark. The understated acknowledgement of excellence. Final answer. Why did Britain's radar give the UK a power nobody saw coming? Because Samson represents something profound. Not just technology, philosophy. Most nations buy capabilities, purchase systems, depend on suppliers, hope for the best. Britain builds, develops, innovates, from first principles, with patience, with expertise, with commitment. The result? Samson, a radar so capable it detects ballistic missiles when not designed for them. So advanced it tracks stealth targets like cricket balls. So reliable it's virtually immune to jamming. And completely, entirely, thoroughly British. This gives Britain options, independence, the ability to operate alone if necessary, to lead NATO operations, to provide capabilities that allies need. It gives Britain respect, not demanded, earned, through performance, through excellence, through doing things properly. And it gives Britain pride, the kind of pride that comes from carrying forward a tradition, from standing on the shoulders of giants, from proving that British engineering remains world-leading. Every British citizen should know this story, should understand what Samson represents, should feel what those engineers feel. Not arrogance, not boasting, not superiority, pride. Quiet, solid, unshakable British pride. The pride that comes from doing something difficult, building something excellent, showing the world, politely but firmly, that Britain leads. And that distinctive spherical radar, rotating slowly atop Type 45 destroyers, sees more than anyone expected. Tracks targets nobody else can. Performs missions it wasn't designed for. Because that's what British engineering does. Exceeds expectations, solves problems, works brilliantly. When NATO looks at Britain now, They don't see a declining power. They don't see a fading empire. They see technological excellence. They see innovation. They see a nation that builds the future that Samson created, the future that Britain controls, the future that proves, once again, that British ingenuity changes everything, forever.